Okay, so we're going to start with question number 1. Write down the length of the object below, stating the actual measurement and the uncertainty. By reading the number from the ruler, you can see that we have a reading which is somewhere in between 2.7 and 2.8. 2.7 something, right? So we're going to leave that as 2.75 approximately, but we can tell that it's definitely somewhere in between 2.7 and 2.8. So therefore, your uncertainty must be to the same decimal places. That's right. So if we now do decide what is the uncertainty in that last one, it's 0.0. Well, it's an analog instrument, so therefore it's half of the smallest division. The smallest division is 1 millimeter. Okay, so that would be 0.05, which is half of 1 millimeter in this ruler. If that's our absolute uncertainty, then our fractional uncertainty would be 0.05 over 2.75, and our percentage uncertainty would be 0.05 divided by 2.75 times 100. That would give us an answer of 0.02% to round up to one significant figure as a fractional uncertainty, and as a percentage it would be 2%, which is what you get when you multiply 0.02 times 100 to give you this. For question number 2, you're calculating the uncertainty of a set of repeated readings. In order to get the uncertainty of a set of repeated readings, you first need to find your average, and then from your average you work out your maximum and minimum deviations and divide those by 2 to give you the center point of that range. So in this case, average is 4.68. Our maximum value is 4.85. Our minimum value, 4.5. So to find half of the range, you subtract 4.5 from 4.85 and divide by 2. That gives you 0.175. And we're going to keep it to the same number of significant figures. So we round this up to 0.18. You can't really see that. 0.18. Okay, to just repeat, how did we find that? Our maximum value, our minimum value, you subtract 4.5 from 485 to give you this range, and then you divide that by 2 to give you 1.75, and you round that up to give you 1.18. So the uncertainty is plus or minus 0.18. For question 3, the square has a length of A equal to 4 plus or minus 0.1 meters. Now, what is the length of the perimeter? The length of the perimeter is 4 times A, or A plus A plus A plus A. This is an addition of uncertainty question, and the rule for the addition of uncertainties is that you add the absolute uncertainty of A. Now the absolute uncertainty is 0.1, so the uncertainty in total of 4 times A would be 0.1 plus 0.1 plus 0.1 plus 0.1, which gives you 0.4. That's right. Okay, so that 0.4 meters is your uncertainty. And of course, the value, because we want the length of the perimeter, is 16.0. So the final answer is 16.0 plus or minus 0.4. So if now we go on to question 3, we have if A equals 6 plus or minus 0.1 and B equals 5.4 plus or minus 0.1, we're going to see what happens when you do A plus B and A minus B. Now again, we're following the same rule. We are adding an uncertainty, so therefore the answers to both would be 11.4 and 0.6 respectively, and the uncertainty for both would be exactly the same, plus or minus 0.1 plus 0.1, 0.2, because the rule is to add the uncertainty. Number 4, we are now starting to look at multiplication and division. As you might remember, I hope you remember, the rule is now, because you're multiplying or dividing, the rule is that you must add the percentage uncertainty or the fractional uncertainty of each term. Okay, so we're not dealing with absolute uncertainties, we're dealing with the fractional. So let me tidy this up. Okay, so we're working out speed, which is distance, which is 100 meters, divided by time, which is 8.6 seconds. If we work out the actual value, 11.6, then we work out the actual value, you get 11.6 meters per second. And now we set up our fractional uncertainties. The fractional uncertainty in distance, 0.1 divided by 100. The fractional uncertainty in time, 0.1 divided by 8.6. And we add these up, they'll give you the fractional uncertainty in the speed, which is delta S over 11.6. So if we solve for that, you should get an answer of 0.15. Let's try the next question. We have 3 quantities, x, y, and z. And x has a percentage uncertainty of 4. Y has an uncertainty of 5. And z is has a percentage uncertainty of 3. I seem to remember that was what I said at the time. Okay, if I've made a mistake there and the percentage uncertainty is different, then use this as an example to work from. Okay, it might not give you the same answer as in the test, but I'll work through it using 3%. I can't quite remember exactly what I said, so hopefully this will be helpful anyway. Okay, so let's have a look and see what happens if we need to find the percentage uncertainty in A, right? If the value of A is 4 times x times y. Now the 4 in this kind of question is a constant, and because we're dealing with fractional uncertainties, then the 4 is now irrelevant. We don't need to multiply it by 4 because we're not dealing with the absolute uncertainty. Okay, so all we're doing is using the rule. We are adding the percentage uncertainties when we multiply. Now the actual value first, the value is 4 times 3 times 4, okay, which gives us 48. And then the total percentage uncertainty would be the percentage uncertainty in x and the percentage uncertainty in y, which is 4 plus 5, which equals 9%. Okay, now that you know the total percentage uncertainty, you now need to work out 9% of 48, which you can either do directly using a calculator or dividing by 100 and multiplying by 9. So you get an answer of 4.3. Okay, which, if we want to be really fussy, we've got significant figures. Okay, if we respect, we would round this one up to a 4, plus or minus 4, but I would accept this as a correct answer. Okay, so that's our absolute uncertainty, 4.3, our percentage is 9, and our value is 48. So let's do exactly the same thing with 4 times x divided by 9. Now, working out our actual value, it's 4 times 3 divided by 4, which gives us 3, basically. You're cancelling those 4 out. And you are finding the total percentage uncertainty, so with the percentage uncertainty in x plus the total uncertainty in y, so that would give you a total of 9%. Exactly the same as before. Okay, now what's 9% of 3? Will give you a value of 0.27, which will round up to 0.3. Okay, so let's leave that there. We won't talk about significant figures at this stage. I just want you to practice the calculation. So that would be your absolute uncertainty, and this would be your percentage uncertainty, and this would be your value. Let's try the last one. Okay, so now if we do the last one, we have yx squared over z. So let's try putting some values in. 4, which is y, x is 3 squared, x squared, over z, which is 8. And if we calculate the value, we get 4.5. And now let's work out our percentage and our absolute uncertainty. Well, we've got a uncertainty in x of, change colour there, we've got x is 4%, 8 is 3%, and in y it's 5%. But of course this is to the power of 2, so you multiply this by 2 to give you 8%. Okay, because when you square a value, the percentage uncertainties are added. Okay, or you multiply it by the number of the power. So in total, we have 5 plus 8 plus 3, which will give you 16%. Okay, now once you've got that percentage uncertainty, you just find 16% of your value 4.5, which gives you 0.72. Okay, so just check through this and see if you get the same answer. If not, we can talk on Monday. But yeah, I think if you can do this, watching this video, and go back to the original video that I did on the different types of uncertainties, you should be all set for the quiz or the test tomorrow.